Hello, everyone, and welcome to this latest webinar from Omdia, a division of Informatech. Our topic today is Wi-Fi 6 and 6 GHz Wi-Fi 6E, transforming the wireless landscape. With 5G commercial rollouts well underway, discussion is now turning to Wi-Fi 6. But today, our panel will explore the benefits and use cases for Wi-Fi 6 and if it will compete with or complement 5G. Our webinar is co-presented by Omdia and our partners Anritsu and Qorvo. My name is Alan Tatara, Senior Event Manager for the Omdia webinar team, and I want to thank everyone for joining us. But before we get started, let me just take some time to highlight some of the features that are available for you on our webinar. So the console that you're looking at is completely customizable. So you can open, close, move, or even resize any of the windows that you have open on your screen and arrange the console any way you like. Now, at the bottom of your console, you're going to see a number of application widgets. Make sure you check these out during the webinar. But I do want to mention the resource list widget because this is where you're going to find additional material about our topic, including the downloadable slide deck from today's session, as well as other valuable information, including a special report authored by analyst Yogita Kanisan. You're also going to see a Twitter widget as well, which means you can tweet directly from within the console. And today we're using the hashtag Wi-Fi6. We will also have a live Q&A session directly after our presentation, so please submit your questions or comments at any time throughout the webinar by using that Q&A box that is on the left side of your screen. Please note that this webinar is being recorded and that the on-demand version will be sent out to you within about 24 hours. And if you experience any technical issues whatsoever, just click on that question mark widget and you will receive the answers that you seek. So now let me take this opportunity to introduce our panel. First leading our discussion is Yogita Kanisan. Yogita is a senior analyst in the IoT connectivity segment at Omdia. We are also joined by Craig Hendricks. Craig is a senior business development manager at Anritsu. And rounding out our panel, we have Tony Testa. Tony is the Director of Marketing and the Wireless Connectivity Business Unit at Qorvo. So welcome to our panel. We are honored to have you with us today. So now let me turn things over to Yogita so we can get started. Yogita, over to you.
Thank you, Alan. Good morning, good afternoon, good evening, everybody, wherever you are. So given this current situation, I hope all of you are staying safe. Thank you for joining us today. We will be discussing a very interesting topic today, which is the features and benefits of Wi-Fi 6 and Wi-Fi 6E, which is the latest addition to the Wi-Fi family, and how these standards are transforming the wireless landscape. So before we proceed with the discussion, I would like to briefly go through the agenda for this webinar. As part of our discussion, we will be looking into the market adoption for Wi-Fi 6 overall, and how these markets, these applications are driving the demand for Wi-Fi 6 embedded devices. This discussion will then lead to what triggered the need for a new Wi-Fi standard, and what are the existing connectivity problems and challenges that could be addressed by Wi-Fi 6. Most importantly, we will be sharing the interesting features and benefits of Wi-Fi 6. How are they different from the previous Wi-Fi standards? Also not leaving out the biggest announcement in Wi-Fi industry, which is this year, which is the availability of 6 GHz band exclusively for Wi-Fi 6. And why will this be a revolutionary change to the Wi-Fi industry? We will be also walking through the details of the spectrum expansion and the status of the regulator's approval for the 6 GHz band. Towards the end of this webinar, there will be a question and answer session with the audience. So please submit questions that you may have so that we can address them towards the end of the session. So let's jump right in. So since its introduction, Wi-Fi has undergone massive changes. Over the years, the traffic that Wi-Fi carries has also changed tremendously. Today's Wi-Fi carries around approximately 14 times more video traffic, which is almost 75% of all IP traffic that traverses the network today. So this shows that wireless is really evolving and is driven by the constant demand for faster internet by more and more connected devices in the network, especially as we consume more bandwidth-hungry applications. So this only proves that the future network is going to need more wireless capacity and reliability. Wi-Fi 6, or also known as 802.11ax standard, is the latest step in the journey of the wireless innovation. Wi-Fi 6 introduces new sets of capabilities which can be used by various industries to address a whole new set of opportunities which were not able to be addressed by the previous Wi-Fi standards. So if you look at the chart on your right, Wi-Fi 6 has been showing rapid momentum in the market. As you can see, it's being rapidly adopted by high-volume applications such as mobile handsets, consumer and enterprise routers. So Omdia forecast for the next 3 to 4 years, Wi-Fi 6 technology will be adopted rapidly in mobile handsets, enterprise and consumer CPE, such as routers and gateways, portable computing devices such as laptops, tablets, and also desktop computers. So the pattern of penetration into the market for Wi-Fi 6 is actually pretty similar to the previous Wi-Fi standards. For example, upon introduction, Wi-Fi 6 was first adopted by high-end wireless devices such as routers and smartphones. But however, if you look at the year 2019, major smartphone manufacturers such as Samsung and Apple introduced Wi-Fi 6 as their Wi-Fi solution for premium phones launched last year, which is the Samsung Galaxy series, the Galaxy Note series, and the iPhone 11 series. So compared to the previous Wi-Fi standards, Wi-Fi 6 was fast to be introduced in premium phones, hence driving the number of integrated chipsets shipped in 2019. For Wi-Fi 6 enabled tablets, it will normally take about 6 to 12 months to trail smartphones. So if you look at the carrier Wi-Fi market segment, the Wi-Fi 6 standard is expected to be rapidly adopted by carrier Wi-Fi 6 Wi-Fi access points from 2019 and beyond. So Omdia forecasts that by the year 2021, the carrier Wi-Fi market segment will be dominated by Wi-Fi 6 standard. This is pretty similar with the enterprise and consumer Wi-Fi equipment market as well, as the transition to Wi-Fi 6 will be inevitable as more consumers upgrade to the next generation equipment. Of course, in the current situation, which is the rise in the COVID-19 pandemic, for the past 2 weeks, there has been rapid transformation in many of the vertical markets forecasts. There will be an impact to the device shipment in all these categories for the year 2020, which we have adjusted in this table, in this chart. However, the COVID situation has triggered interesting surge in residential Wi-Fi, as staying connected is critical in times of isolation. So there has been a surge in Wi-Fi traffic due to people working from home, streaming videos, and online entertainment such as Netflix, which requires high bandwidth usage. So this increases the need for high speed and high bandwidth connectivity at home, now that Wi-Fi needs to support multiple concurrent users. So we might be seeing a surge in demand for Wi-Fi 6 enabled devices, especially routers, handsets, and portable computing devices. So one of the biggest areas of potential for Wi-Fi 6 is to provide carriers and public network operators with more capabilities to support connectivity in public venues. So the network coverage and capacity demands in public venues, especially due to the population density in environments such as airports, convention centers, stadiums, health campuses, or education campuses, drives the demand for bandwidth. And compared to the previous Wi-Fi standards, Wi-Fi 6 has the capabilities to support the network demand in these high-density environments. We will look into the features and benefits as we progress through this webinar. And you can see why Wi-Fi 6 can support the network traffic in the public environments. So as to date, Wi-Fi 6 has been implemented in many sports arenas, airports, and other public venues across the globe. Though in the current situation, we might not be seeing much Wi-Fi traffic in public environments. Probably this situation would change in the coming 3 to 6 months, hopefully. So next, to discuss the current problems and challenges that Wi-Fi 6 will be addressing and why we do need the need for speed, I would like to pass over to Tony. Tony, over to you.
Thank you, Yogita, and certainly want to echo well wishes to our listeners and families during these troubled times. So you're going to hear a lot of sort of repeating core messages when we talk about Wi-Fi 6 and certainly the Wi-Fi 6 extended range. First and foremost is speed. And this chart really depicts a great comparison of some of the standards, both licensed and unlicensed, and where Wi-Fi is fit into the picture over the legacy standard evolution, as well as where we are in 11AX, and certainly a continued roadmap for extension in the future. You'll see a very good relationship with licensed technologies, as well as Bluetooth and Zigbee and other lower power, lower range technologies. This appetite for speed continues to drive, technology evolution and standard evolution, and hence brought the current 11AX standard for Wi-Fi 6 today. The second main kind of topic will be capacity. And you can see just this monumental growth as we look at Wi-Fi 5 and Wi-Fi 6 in terms of use cases. And this evolution is really just at the forefront, right? You can certainly see things such as virtual reality, smart home, cloud interface, monitoring and video capabilities. We will see a lot more between industrial use, office use, home use needs to really drive capacity. Not only in the number of users and the type of data capacity that's in there, but also just the number of connections and devices that will be connected into a Wi-Fi network in each of these locations really draws from the flexibility that the Wi-Fi 6 standard brings. And Craig will talk a bit about that here in the future. Okay, and 6 key elements as well as we look really into Wi-Fi 6. And I'm going to subcategorize these into really 3 of these repeating messages. We've talked about capacity already, and if we really look at the extended coverage, the resolution interference, and also the 4-time end users, I mean, that really drives capacity, so 3 of those bubbles. The bottom right, of course, increasing speed with multi-user MIMO capabilities, again, drives that speed need in terms of the Wi-Fi 6 results. And then efficiency improvements and reduction in size really drive that third element, and that is size. When you look at the rollouts today, when we look at distributed Wi-Fi in homes, enterprise networks in campuses and industries and large locations, and of course outdoor, there's been just a continuous drive to make devices smaller and smaller, both for cost-effective reasons as well as just aesthetic reasons, as we have more placements throughout the home. And these 3 factors, speed, capacity, size, drive a lot of what Wi-Fi 6 can bring to the realization in the industry. So as we move forward into the next agenda item, we'll have Craig step in and talk a bit about the specifics and technology within Wi-Fi 6. Craig?
Thank you. So as was mentioned, there's going to be a 4-time improvement in dense environments where the Wi-Fi 6 is optimized to increase the average throughput for users in these dense and congested environments. Largely because previous Wi-Fi was all contention-based, and the Wi-Fi 6 allows some scheduling at much smaller slices than before. Before you could only schedule it at 20 megahertz as the minimum slice, and now they can slice it all the way down to 2 megahertz in the Wi-Fi 6. There's about 40% faster throughput. There's less overhead. They go up to higher modulation, 1024 QAM, so higher peak rates for single user, increased network efficiency, and better battery life. Because of this scheduling capability, they can give low power devices a targeted wait time to go to sleep and wake it up just in time when its time slot is available. So some of the new things, there's a high efficiency OFDM in the previous Wi-Fi. 256 QAM was the highest modulation you could do. Now we have 1024 QAM, so more bits are sent for each symbol. Increased efficiency using closer frequency spacing of the subcarriers. Before it was 312.5 kilohertz per subcarrier, and now in Wi-Fi 6 it's 78.125. Still not as low as you see in LTE with the 15 kilohertz subcarriers. The OFDMA is another new extension that we have. I'll talk a little bit more about in the next slide, where you can schedule different users on different subcarriers for different time slots and so forth. Support for up to 8 downlink multi-user MIMO and uplink MIMO as well, and uplink OFDM. So typical experiments that they've done in the lab with 8 downlink MIMO and 2 uplink MIMO, achieving up to around 10 gigabits peak data rates for 11AX. 4 different formats. There's the high efficiency single user, there's the multi-user, the high extended range, and the trigger base. You can get more range with 11AX because you can schedule down to a 2 megahertz, and the noise floor between 2 megahertz and the previous minimum of 20 megahertz, you get an 8 dB improvement in the noise floor, which gives you that better range. And as I mentioned, the 1024 QAM higher peak data rates, but this does put some difficult design requirements on the devices to meet the modulation accuracy requirements in order to achieve those high 1024 QAM. And there's also multiple spatial streams. You could have both 2 gigahertz and 5 gigahertz operating at the same time. So this OFDM-A is orthogonal frequency division, frequency domain multiple access. It allows simultaneous transmissions from multiple users at the same time. The picture to the right, you see these different little squares with the green user, the pink user, the gray user, and as I mentioned, each one of those users can have a slice anywhere from 160 megahertz, taking the whole bandwidth, all the way down to 2 megahertz with 26 subcarriers. Contrast that with in LTE they call them resource blocks, and in 11AX they call them resource units. So in addition to this two-dimensional OFDMA matrix or array you see there, there's a third dimension for the MIMO streams. You could have another 3D view of that 2D chart by adding different users getting different spatial streams for the 8x8 downlink MIMO or 2x2 uplink MIMO. So the MIMO MU MIMO is multi-user MIMO. So multiple different users are getting different streams, and MIMO stands for multiple input, multiple output. So for 8x8 MIMO, you would have an access point that would have 8 antennas transmitting to the mobile phone or the device, and the mobile phone or device having 8 receive antennas, and then in the uplink back to the access point for 2x2 MIMO, for example, two antennas on the device and 2 on the access point. At this point, I'll turn it back over to.
Excellent. Thank you, Greg. This is Tony again. So if we take no problem. If we take a look at really Wi-Fi 6, we see just a tremendous energy towards advancing technology via the Wi-Fi 5 standard. Previously, the block diagram depicted here, and I know that the writing is very small, but what you see is the full extent of 8 streams of 5 gigahertz and 4 streams of 2.4 gigahertz. And you'll see the top 2 blocks are 4 streams of 5 gig and 2 gig, added with some filtering and then diplex to the antennas, again, to reduce the size footprint. And then you have on the bottom another 4 streams of 5 gigahertz. This architecture we're showing here is what's referred to often as a tri-band architecture. And what you'll see is if you look at the details in the 5 gigahertz space, you'll see that it's actually split from Uni 1 to 2A, and then the bottom being split from Uni 2C to 3. And the reason that's done is it certainly affords the full use of that 5 gigahertz spectrum today, with dedicating 4 of those streams towards the backhaul communication to make sure there's a very robust network, and then 4 of those streams being used for the client communications to laptops, cell phones, other devices connected into the network. And this really becomes a strong foundation of the distributed Wi-Fi mesh in a home or in a campus setting. What it's created, of course, is new needs already in terms of 5 gigahertz filtering to separate those channels, diplexing to reuse the advanced capabilities of those antennas to transmit and receive both in 2.4 gig and 5 gig. And if we look really to the right, you'll see sort of the key things driven by Wi-Fi 6. And we're going to talk even further about extended frequency here as we get into Wi-Fi 6E and the selectivity opportunities that brings with a much bigger spectrum of use. Craig's talked about the higher MIMO features, advanced filtering I just mentioned. We'll see a lot further coexistence challenges, specifically as we start bringing more technologies into the home. All of this driving needs for further integration, right, to get into that small size factor that we identified as one of the lead vectors. Across the industry, this brings massive investments in capabilities and technologies, and you'll see, advanced semiconductor processes being developed specifically for the high linearity required for these systems, as well as the specific filtering and high frequency filtering that's required. New design architectures, and this really comes into play when we start looking at thermal efficient solutions to get small. You'll see ways to bring power reduction into the devices. That gets augmented by advanced packaging. Right, so new package technologies help with removing the thermal streams into the main board and separating that. So again, you can get more devices into a smaller form factor. And then finally, we get into integration capabilities. And, I did highlight just a couple that we bring to market into Wi-Fi 6 and moving forward Wi-Fi 6E. An iFrame is a technology where we actually are integrating both the active devices like power amplifiers, low noise amplifiers, switching technologies with passive devices. And here we have a demonstration of a BAW filter technology integrated with all the active technologies. And again, when you think of doing that, you've got to, higher the level of integration and how do you get it into the same floor plan and packaging. You've got to consider the thermals and the thermal impacts of having these devices, passive and active, so close to each other. So again, it drives all those core industry technologies further. And then you also see wide frequency BAW plexers coming into play now, right? As we'll see the extension into Wi-Fi 6E, where we get up to 7.125 gigahertz potentially, we're going to have the ability for those diplexers to want to cover that full range, right? So that the radio architectures can bring some of this new selectivity and flexibility into the solutions. Okay, and a couple of filter requirements as we go through just to highlight. So on Edge Boost, here we're really looking at optimizing the frequency spectrum so that you can transmit max power across that full spectrum. And the way to do that is with some filtering that has very steep skirts at the uprise and downrise of that frequency spectrum. And by doing that, the traditional backing down of powers from 3 to 6 dB does not have to happen. What this means for the end users, right, is it creates a max coverage capability across the full spectrum. As everyone recognizes, usually in 2.4 gigahertz, which is where you get a lot of range at that frequency, one of the default settings in your routers would be at channel 6, which is right in the center of the channel because it was able to transmit at full power and not get to the band edges. These new filters actually allow you to get to full power at channel 1 and channel 11. So you get that full spectrum use of all the 2.4, which really brings a quality of service to the market. Another type of filter is band boost filtering. Here you can really focus on the capacity and throughput, and this allows us to split the spectrum as we talked about in that tri-band architecture. So the use case on the bottom right shows splitting Uni 1 to 2A and then Uni 2C to 3, and having part of that spectrum used for backhaul and part of that spectrum used for client communications. Another filter type is coax boost, where really you're looking at coexistence between the different technologies. And obviously there's a lot of 2.4 gigahertz cellular bands, band 7, band 40, band 41 that are close into the Wi-Fi frequency. And then certainly others that reuse the same spectrum as we look at Bluetooth Low Energy, if we look at Zigbee. So these technologies really need to have coexistence filtering so that you can concurrently run and operate both the cellular operation at the same time as Wi-Fi and these other standards. And as we talk about the cellular side, we really want to press the fact that we see Wi-Fi 6 and 5G as very cooperative solutions. A way to really envision this, right, is Wi-Fi 6 in a local area context and 5G in a wide area context. And so they really complement each other in these usage. And what we see is that local area and the cost of implementing the infrastructure in the local area is really well suited for Wi-Fi and Wi-Fi 6. And as we continue to add more devices that will lock into that network, really keeps the spectrum free at 5G side and offloads those demands onto this backhaul at Wi-Fi 6, which may end up, communicating back to the cloud via a cable, a fiber, or even a 5G network connection to have high bandwidth to and from the cloud. But in that local area, you use this distributed network to have that communication cycle. Another viewpoint, really, when we look at, short-range, local area networking and wide area networking is the fragmentation, of course, that we all see and live through today, specifically when we talk about the smart home and the different technologies that are used and how to implement that really as a full ecosystem. You've got, of course, the content drivers that are bringing a lot of the data-rich features and applications. And then you have the sense and control mechanisms that are really looking at, monitoring any kind of, device change, temperatures, humidity, pressure, and quick sort of relays for alarm systems, those kind of gating items. And within each of these core areas, short range, local, and wide area, we really believe there's going to be a centralization of the technologies over time that help fulfill the overall smart home ecosystems. You can see in short range, certainly we see Bluetooth and UWB as some key technologies that can really drive that. And we see UWB really in between both the content and sense and control capabilities, given its functionality at the frequencies it plays at. As we move into the local area, again, content-wise, Wi-Fi 6 and Wi-Fi 6E really solves a core capability in that distribution and connectivity. And as we get into the sense and control side, we're seeing a lot of really promising activity in the industry. There's been chip that is now really a conglomeration of multiple major players in the industry working together to have interoperability amongst the technology protocols used, being Zigbee and Thread predominantly in that area. We also see a new technology in LoRa creating a campus area location, really sitting in between the local and wide area, and that's fulfilling a very specific need in range and capabilities. And then certainly as we get into the outdoor and we start talking kilometers and miles, LTE and NB-IoT within the 5G spectrum are really complementary to the overall system, ensuring the ecosystem can roll out. Okay, and now I'll pass back to you, Craig.
Thank you, Tony. So Wi-Fi 6 and 5G are complementary. Many, as was mentioned, many of the top-of-the-line 5G phones support Wi-Fi 6, such as the Samsung Galaxy S10, Note 10, S20, the Sony Xperia, the LG V60, and you get the similar kind of speeds for both 5G and Wi-Fi 6, providing a similar user experience. So when you do get indoors and you want to save your bits and bytes that you are charged for your 5G experience, you can switch over to Wi-Fi 6 and get the same kind of fast speeds. And there are even some non-5G phones that support Wi-Fi 6, such as the iPhone 11, 11 Pro, and 11 Max. Back to you, Tony.
Thank you, Greg. Yep, and I guess an exciting part of the conversation, right, is Wi-Fi 6E. During CES this year, the Wi-Fi Alliance announced the Wi-Fi 6E, which is the extended band. This really goes from 5.9 gigahertz up to 7.125 gigahertz of potential spectrum expansion in this unlicensed band. This is, a massive increase in the amount of spectrum and how this impacts channels both at, 80 megahertz, 160 megahertz available channels of use, specifically in the U.S. up to that 7.125 gigahertz. And then even getting to future spectrum, right? When we start talking about the next generation Wi-Fi, there's already chatter and discussions of getting it to 320 megahertz channels. Again, all this trying to keep up with that appetite for speed, the expansion and capacity, and keeping up with the overloading of the use cases, which will continue to build up the needs for this increased capability. If we take a look, I mentioned earlier about the tri-band architecture where we split the 5 gigahertz spectrum between the lower and upper spectrum. That created a great opportunity to have some dedicated backhaul as well as dedicated client communication that's very secure and a very clean spectrum. We, of course, see activity in 5 gigahertz beyond the unlicensed spectrum, right? So that will continue to get crowded over time. Similar as the 2.4 has several spectrum capabilities with different protocols that operate in that same frequency. And this massive 1.2 gigahertz, 6 gigahertz spectrum in Uni 5 through 8 really helps bring some clean spectrum to use. And so what we see is that tri-band still being effective in having the full distributed Wi-Fi or Wi-Fi mesh coverage. But we see the ability now is to add spectrum to that. So instead of splitting 5 gigahertz, we could make use of that whole 5 gigahertz, let's say, for the client-side communication. And we can use now this full spectrum of 6 gigahertz to be that very clean, dedicated Wi-Fi 6 backhaul. And so it becomes almost greenfield in the need for not having to have legacy standard capability, right? So there's no 802.11b or G or N in that 6 gigahertz spectrum. So it is Wi-Fi 6 and forward capabilities, and that brings some great usage of new channels to use to really facilitate the execution and gain in capacity and speed. Okay, so that Wi-Fi 6E enablement, again, largest unlicensed potential offering from FCC and a lot of activity, and we'll talk about that here soon in the industry for that. Greenfield, again, in the sense that it certainly is not having to be backwards compatible to legacy standards in Wi-Fi. Certainly there are activities in 6 gigahertz we've talked about. We've mentioned UWB already in some previous slides. So there certainly will be other uses of the spectrum, but a lot of opportunity here to create segmented segments of this filtering, again, as we had within 5 gigahertz and splitting up this coverage to have lots of use case potential. And then certainly it sets the stage for Wi-Fi 7 and beyond, right, as we get into next generation growth.
And there is also plans in later 5G releases to use 5G unlicensed in that same 6 gigahertz band.
Excellent point. Absolutely right. So we'll see that continued use to augment as similar in 5 gigahertz spectrum as it had. Great point. Okay, I'd like to talk a little more again about just the realization of the smart home or the smart campus and looking at all these different technologies and why Wi-Fi plays such a predominant role. If you look at this pod in every room distributed architecture, you can see sort of the circles in black are the main gateway and the routers and extenders and a Wi-Fi network. And the frequencies mentioned here can be changed. Specifically, as we get into this new Wi-Fi 6E, you'll see maybe 6 gigahertz being used as the backhaul, potentially with 5 gigahertz full spectrum being used as communication to the clients. But you'll see the demand on these nodes really help solve one of the core overheads in bringing all these different technologies to market, right? And that's the meshing or the interconnectivity of that, and eventually the communication back out to the cloud to take that data, process it, and bring it back for actions on those nodes. What the Wi-Fi distributed network does is it really creates that ecosystem to do that and do that quite naturally. So whether it's a core router in your house with extenders that is creating this network, if it's a gateway system and you have multiple set-top boxes that are distributed that add this functionality, you end up having, 3 or 4 core-centric devices that can mesh on the Wi-Fi side, and then adding things like Bluetooth and Zigbee versus, creating an overhead on those systems that also have their own meshing technology creates a natural capability to just spread this data and information. Further, we see more connectivity to those nodes, so you'll see voice becoming very prominent in being able to have voice commands to activate the smart home and smart campus features. You'll certainly see, again, WiGig and UWB connectivities that'll start bringing new use cases to the market. And so it really creates a sound foundation for the industry of what Wi-Fi 6 can bring. And I think we're going to show another slide here upcoming that talks a bit about the Wi-Fi 6E trials and the success rate they had. So I will pass it back to Yogita.
Thank you, Tony. So, yes, well, just briefly after the announcement of Wi-Fi 6E Wireless, Broadband Alliance announced the first phase of the Wi-Fi 6E trials, which was around early March this year. And the trials conducted will use the Wi-Fi 6E capable mobile platforms from and also laptop equipment from Broadcom and Intel. So during the enterprise trial, which took place in San Jose, California, speeds of 2 gigabits per second were achieved, which is very comparable to the 5G cellular service speeds. And the trial also showed the results of a consistent 2 millisecond low latency connection. So with this speed and low latency, Wi-Fi 6E can be an ideal solution for both consumer and industrial solutions such as VR and AR. So the next stage of Wi-Fi 6E trials is scheduled to take place over the coming months. And this will include subway transportation systems and also in-home testing. So I would like to pass to Tony back to discuss about the status of the regulator approvals for the 6 gigahertz plan. Back to you, Tony.
Absolutely. Thank you, Yogita. And just to go through this, there's a lot of words, a lot of detail on these slides, and of course they'll be in the presentation, so I won't get very detailed into this. But certainly just want to highlight the activity and a lot of the industry excitement to open up this spectrum. Really, if we look at it globally, you'll see certainly the U.S. excited to get all the way up to the full 7.125 gigahertz. What we see right now, of course, there's been complications with the COVID-19 and how that interacts with the ability to have these sessions, but we're still very hopeful and looking towards a late April opportunity to get potentially some approval movement into this. And again, as you see, it really supports 802.11ax devices only. So it really creates this clean spectrum for use for us in the Wi-Fi space. And then certainly, as we mentioned, there may be more unlicensed uses from different standards in this spectrum moving forward. And really, again, when I mention across the industry, I mean, it really is across the industry, right? Here's an example of a Big Ten letter that was sent up to the FCC secretary, and You know, a lot of kudos to the team members that helped put this together, but it really shows the major ecosystem and overlap and use models and use case models of how important Wi-Fi is, how, you know, redundant in its capabilities and really dependable it's become. And I think we're all living through it today, right? When you look at the usage model of home use of Wi-Fi and video streaming and connectivity and working from home models, it's really become to the forefront of that, and this new technology evolution and new spectrum really help continue to advance that forward. Okay, and to take a look at the European side in Ofcom, again, here we've got, again, a good chunk of spectrum. This would take us up to the 6.4 gigahertz, which is essentially 6 new 80 megahertz channels or 3 new 160 megahertz channels, and certainly facilitating the path of having a 320 megahertz channel in there in the future. So 100% increase, right, in valuable operational frequencies in the UK alone with this proposal moving forward. So a lot of excitement across the industry, and it doesn't stop there when we talk about the use of spectrum. And one of the proposals I wanted to just highlight, again, is finding ways to even get more use out of the 5.9 gigahertz band. So there is an NPRM up to be discussed within the FCC to really look at ways of promoting further innovation and use of the 5.9 gigahertz channels and Uni-4 specifically. I highlight this because, you know, I talked earlier about, again, the need for speed, capacity, for size, and how, you know, Wi-Fi 6 and Wi-Fi 6E create the opportunities to really drive the industry and technology. This becomes significantly important, right? There is already a very narrow band in between, you know, where Uni 3 ends today and where Uni 5 begins, and which filtering capabilities and requirements need to be used to make sure you can concurrently use those channels. If we actually add this frequency, which is fantastic in terms of adding new channels and functionality, it creates further demand on the technology evolution to create either new filtering technologies, broader band PAs and LNAs, more switching requirements, new ball plexers that can handle, you know, tuning the antenna or flexible for the antenna for that full frequency spectrum, and continues to create just this engine that drives the industry forward. And what we've seen is it's always responded, it's always brought this capability, and again, it works hand in hand, we see, with 5G technology to really enable all these new use cases. Okay, and with that, I'd like to pass back to Craig and talking about some specific capabilities.
Thank you, Tony. So Anritsu is a manufacturer of test equipment. I'd like to highlight the Anritsu MT8862, which is a tool for measuring RF performance for commercial Wi-Fi products with very simple setup. It supports 802.11 AB, GN, AC, and AX. It can act as either an access point or a station for testing either one. There's an option for testing with security turned on, such as WEP, WPA, WPA2. It has auto-adjust power and channel and station mode connection. Has a very wide dynamic range. This is important. A lot of times people want to make measurements instead of with a conducted cable from the Wi-Fi device. They want to do measurements over the air, and this extra dynamic range we have helps maintain that connection over a radiated connection. We have a unique data rate control patented capability for being able to drive the data rate to whatever encoding scheme to whatever you want to do your testing at. A connection preservation capability to be able to change settings without having to disconnect and reconnect. And easy setup for receiver sensitivity, where it'll just sweep and give you a little plot of receiver sensitivity versus input level. Also, it has a built-in embedded web server, so there's no software to install. So any PC with a web browser, you just browse to the IP address of the box, and there's your GUI. And sniffer tools to be able to save off Wireshark logs for troubleshooting. And even an internet connection, you can connect the back to the live internet and do your testing with actual live data instead of just pings or null packets. And in addition to the 8862, Anritsu also provides other products for 5G and NB-IoT and Bluetooth, etc. I'm going to pass it back now to Tony.
Thank you, Craig. Yeah, and I'd like to bring, make sure we've got the visibility here. Sorry, jumping on slides for a second. The core Qorvo building blocks, and certainly Qorvo as an organization has multiple different vectors, but when we look specifically at Wi-Fi 6, there are tons of activity both in the consumer premise side as well as the mobile side that creates new product categories. And really going forward, I mentioned a lot about sizing for the small implications and the higher integrations of the end products, as well as facilitating the speed and capacity needs. And really we see, again, the core thermal and robust devices being used, and these are power amplifiers, these are BAW filter technologies at 2 and 5 gig and above. These are low noise amplifiers and switching capabilities, and then integrating all those functions into a single placement device. And that's where the iFEMs, integrated FEM, comes into play. So this is really plug and play, and why this is important is, as you see the need for getting to small size, as you can imagine, range ties very closely to power output of a device, right? The more power you put, of course, the further you're going to get in range. As you try to make a device smaller, those high-power devices also create a lot of thermals, and you now have to manage those thermals, right? And every device and function and feature you add in that chain between the transceiver and the antenna are adding additional losses and transfers that have to occur. By integrating all that internally and not having different placements and components and matching that are typically done in a circuit design, we reduce a lot of that redundancy and design requirements, and we integrate that all on chip. And it makes it, really focused on getting time to market, making the designs more simplified, handling the thermals within these components to allow for those small designs. Further with that, Qorvo brings, augmentation into the low power systems. So we have complete transceiver and SoC solutions that can currently operate Zigbee, BLE, and Thread, RF4CE in a single placement device. It's very unique in the market for this placement, and really a lot of focus as we see the excitement and the chip activity underway in the industry to tie into that and bring the interoperability expressions that really will realize the smart home and all this internal IoT Wi-Fi functionality. So a lot of exciting products, again, very similar on the mobile side in terms of cellular handsets and the integration levels we do, and we continue to augment this forward. Okay, with that, I will hand back to Yogita.
Thank you, Tony. So we are towards the end of the webinar. Now, just to summarize, it is evident that Wi-Fi 6 provides major improvements for local area networking capacity and transfer rates. The capability in this technology drove many industries to create new products capable of supporting cellular offload requirements. And with the access to 6 GHz band, Wi-Fi 6E further expands Wi-Fi capabilities, providing channels for wide bandwidth and future system upgrades. And also recognizing the importance of having the access to 6 GHz band, industry players are driving the legislation, like how Tony explained earlier, on how the entire industry players are approaching FCC to approve the additional spectrum to be made available for Wi-Fi 6. And to conclude, it has been a while since the Wi-Fi industry experienced a revolutionary change. So what took years for the previous standards to be adopted is only taking months with Wi-Fi 6. So with that, probably we can go to the question and answer session. Tony and Craig, there's a lot of questions from the audience. Okay, so one of the questions is probably to Tony. What is the readiness or sampling of products specific to Wi-Fi 6E now that the whole market is looking to engage, and certainly with some gaps to product readiness at this early stage and the uncertainty in the legislation. So Tony, would you like to answer that?
Sure. Yeah, thank you. It's a great question, right? Because excitement on this has already been brewing for some time, as you can tell by the Big Tent letters and activities underway, and even announcements from the chipset providers, both for the CP side as well as the mobile side of having the capabilities. So when we get to the more front-end technologies, the filtering technologies and the antenna technologies, there's certainly a longer roadmap, right, in terms of production readiness in most cases for that. And the reason is we're trying now to have almost a more flexible front end, ideally, in the solutions that are covering a much broader bandwidth. That creates a lot of trade-offs in the design as you try to optimize, again, for enabling the small size and the thermal impacts. So those technologies are underway. Qorvo itself had demonstrations on multiple sites during CES already in January that showed and demonstrated the Wi-Fi 6E capabilities. We're sampling, preliminary devices today. I would expect systems in the market probably by the end of this year to start maturing and being released, even if the ratification and certification is not fully enabled. The capabilities in some of those early devices will roll out. And as mentioned, we're seeing it across both spectrums of the CP side, right, the infrastructure side, as well as the mobile side, both actively involved and anxious to get product to market.
Thanks, Tony. So there's a few questions actually that mostly revolves around how does Wi-Fi 6 complement 5G. So probably to both Craig and Tony, would you like to take that question? So the question is, how does Wi-Fi 6 complement 5G? And probably you can discuss on how they can coexist either at home or at public place in terms of speed or in terms of best connectivity.
Sure, I'll take a quick step.
Go ahead.
Excellent, Craig. I mean, what I was just going to say is we talked a bit certainly about the local area and the wide area networking of it, and I think that really comes in play when you look at some of the millimeter wave and high frequencies and some of the restrictions of passing that waveform through a building and house and disruptors. Wi-Fi really becomes well suited in that indoor space, if you will. Now, that doesn't mean there won't be 5G capabilities. We'll see 5G entering its way into gateways and other devices, and even having transposer type devices, if you will, on the side of a home that'll take a millimeter wave, signal and then transload it or offload it into Wi-Fi to help distribute through the network in the house. So again, I think they work very closely. That 5G by far adds a lot of capacity and strength in terms of the amount of data throughput it could handle, and using that as a broadband technology, from the home to the cloud or from the campus to the cloud will be very useful. Wi-Fi really resonates very well indoors still, right, for all those components and devices to interoperate with. Go ahead, Craig. You have more thoughts?
Yeah, so like you said, Wi-Fi primarily indoors. Cellular adds the wide coverage and the mobility, so wherever there's a hole in the Wi-Fi, you can plug that with the cellular coverage. Because cellular goes all the way down to 700 megahertz that penetrates buildings, much better than 2.4 gigahertz Wi-Fi would. On the other hand, there is cellular, as you mentioned, that will be used indoors. There is the millimeter wave, which is really only line of sight. So it's not even going to pass through any kind of walls really much at all. And there even for LTE, there was, for 4G, there was something called LAA, where they would put aggregated unlicensed carriers in the 5 gigahertz band and aggregate with that with a licensed carrier. But it's still pretty minimal coverage, and it's similar kind of thing for the 6 gigahertz band. Future releases of 5G plan to offer LTE unlicensed in that 6 gigahertz band, but it will probably be in places like an airport or Starbucks or certain places. Certainly not in your home, I wouldn't think quite so much. So it'd be up to whoever owns the space to decide. I saw also that in February, Qualcomm submitted a request to the FCC to set aside part of the 6 gigahertz band for synchronous operations, which would allow for more predictability between how the Wi-Fi 6 and the 6 gigahertz band and the 5G unlicensed would operate. So those are my comments.
Thank you, Craig. So then one more question. What is the principal distinction between a consumer and enterprise Wi-Fi 6 access point?
Excellent.
So Tony, would you like to? Yeah.
Sure. I saw this pop up to our list. And again, just a big thanks to everybody. There's a ton of questions that came in, so really appreciate all the participation. On really the main distinction, if we look at consumer side and enterprise side, is the consumer side really has a certain relegated area, right? Your full home coverage. The amount of spectrum could be more narrow to really facilitate the use cases and the environment. The number of users typically is far less, right? If you think of it from how many connections you have in your home versus if you're in an airport, if you're in a business campus or a stadium-like event. What we typically see is the enterprise devices really designed for utmost flexibility in managing those connections. And what I mean there is the full uses of the spectrum. Using filtering type devices to be able to have max power across all channels, for example, is a great enterprise use case because you get that quality of service and the ability to flex and move around channels versus if you're at home and you're in the countryside and there's not a lot of RF, disruption near you. Relegating your range to a single channel is probably fine. You probably won't have to bounce too often. The other thing we see is certainly within an enterprise side is they will lean forward for those capabilities that are upcoming to make sure the install base and the rollout has that flexibility as it's needed. So 7 gigahertz, for example, right, is you really want the ability for any one of those streams that are being, used within an enterprise system to have the flexibility to be at, 5.9 gigahertz, 5.4 gigahertz, and then all of a sudden jump to, 6.8 gigahertz if that's the best channel to get clean communication for that user or the provider side of that. So it really is just probably a bit of a wider range when you think of enterprise versus consumer side, both in the geography and coverage as well as the amount of flexibility required to really have honed in the types of communication connections. I hope that answered well for you.
Thank you, Tony. So there's one more question that we can take. Before taking that question, there were a lot of questions on the first slide, the chart that was missing the X and Y axis. I'm sorry about that. That was a technical glitch. But we will be having a companion report sent to available for all the attendees. So the chart is visible will be included into the CR report. So probably one more question for Craig. How will the non-Wi-Fi 6 capable devices benefit from this Wi-Fi 6 routers? Craig, would you like to take that one?
Actually, if we have a quick one, there's a question here. If a phone supports 5G, does it also support Wi-Fi 6? The answer is no. There are a number of 5G phones on the market that don't support Wi-Fi 6. But the premium ones do.
Perfect. I think we are top of the hour now. So I'll pass this back to Alan.
Thank you, Yogita, and I want to thank everyone for participating on our webinar today and for submitting your questions and comments. As we have indicated, we received a ton of questions, So our panel will be following up with you via email after the webinar to address all those. I do want to thank Yogita for leading our discussion today, and also for Craig from Anritsu and Tony from Qorvo for this very detailed and engaging discussion. We do appreciate your time with us today. An archived version of this webinar will be made available shortly, sorry about that, and we'll be sending you a follow-up email on how to access that archive, so feel free to come back again, view this session, even pass it along to your colleagues. There will be a survey that will pop up at the conclusion of this webinar, so please take a few moments to fill that out. And please continue to follow us on Twitter and LinkedIn for information on future webinars from Omdia, brought to you by Informatech. So again, thank you for joining us, and have a great rest of your day.